This video is in collaboration with Guardsquare, a platform dedicated to protecting your mobile applications against reverse engineering and tampering. The section with Guardsquare will be in the timestamp below to highlight my thoughts. Recently, I've been diving into the world of the unknown, that is Android application hacking, something I've never explored before. Our mobile OS environments, they often are overlooked in the context of security, but they're very important. And so I thought, you know what, why not venture into the world of Android application hacking and just kind of understand the basics. Now, by no means am I an expert, I'm very much so a beginner. So let's understand the basics of Android applications, hacking techniques, and things that you can perhaps do as a defender in this space. A quick overview of my environment. So here I am on Android emulator. It is a part of Android Studio that Google provides for free. Here you can see a Google Nexus device that I have up and running on the right, as well as a APK called Insecure Shop, which I will dive into in a few moments. So speaking of APK, in the context of Android application development, the APK is the final installable file that a developer will upload to Google Play, which will then be propagated out on Google Play Store. Now, these files serve as the foundation of your entire application stack, and I'm going to quickly review some of the basic primitives here. As an attacker, you definitely want to familiarize yourself with these primitives. As we will see when it comes to decompiling the source code, this is where we are going to go to. But first, let's just overview the basic main primitives. First, we have the Android manifest. So this is the blueprint of your application. This defines the permissions, as you can see here, maybe internet, read external storage, and components like archives and services. Next is classes.dex. So this is where your code is executed and run. We're going to run a decompiler in this in a few moments, and you may notice the .dex extension. This means it is a Dalvik bytecode. I'm just learning that myself. So this is basically where we are going to run the code. We have a resources bin. Here we can see all of the different types of fonts, colors, things of this nature. In addition, you may or may not have a lib library. This is going to be the libraries where you're going to compile for the different architectures. So think ARM, x86. You won't always see it, so Insecure Shop doesn't have a lib folder. So when it comes to deploying your Android application, I had mentioned that .apk, that is one way that you can upload to the Google Play Store, but most developers now use Android app bundles, which basically allow you to upload your APK, and Google will run some different backend resources to help you with optimization. So you really don't have to worry about optimizing for different architecture sets. Just a quick call out there. We're interested in the offensive components, putting on our attacker hat. We're looking to see how we can perhaps look at Android applications and maybe hack them. And so attackers will often use reverse engineering as a means of looking in the underlying app code and running dynamic, passive, and static analysis on the Android application to perhaps understand the logic and exploit maybe a hard-coded value or some different logic gaps. As a working example, as mentioned in the beginning, I have deployed Insecure Shop. This is an Android application developed by Okta engineers a few years ago, which come riddled with a whole bunch of vulnerabilities, some things that they see out in the wild. It is a great security exercise, or CTF. The GitHub link will be in the description below. I do want to quickly call out that I am running through a write-up that I found on Google. So no, I am not deploying these attacker techniques as in I'm finding them by myself. I'm very much so a beginner. So I'm looking at the various different types of primitives and attack techniques and tools that hackers will use to go out and actually decompile your application. I'll also leave this in the description below. Android application hacking has three primary types of techniques that attackers can deploy. There's static analysis. So this is decompiling into the source code and looking at the application logic. And here you're maybe looking for hard-coded secrets, maybe a vulnerable code, or something just out of the ordinary. Next is passive analysis. This is where you insert the Android device as a proxy in between the application and perhaps a logging tool, as we will see here in a few moments. Here you're just looking maybe for insecure logging and other different primitives. And then finally, there is dynamic. This is actually running the Android application, hooking into the various different function calls, and maybe finding some types of gaps in that runtime logic. So as mentioned, I have loaded Insecure Shop into Google Android Studio, and we can load the Insecure Shop app by just going and clicking here. I just drag and drop the APK into the screen, and as you can see, I've already done some research, or I've been doing some testing. So at the beginning of the video, I mentioned that we're going to be drilling into classes.dex, and if you see, we have some subfolders, and from here we can actually decompile to source code. Now, Android Studio will not provide the fully decompiled code, so there are popular reverse engineering or decompiling type tools specifically made for Android, one of them being JDEX. So up here on JDEX, if we go to the Insecure Application APK, I've uploaded this as well as looking into the source code. So going through the COM, we can see the various different types of class function names. And from here, attackers can start to decompile and understand how your application works. Now, in the context of Insecure Shop, there is, as the first exercise, a hard-coded username and password. You would never want to do this, but in a real world, there may be API keys, cryptographic keys, hard-coded string values that application developers are choosing to insert, and of course that is not a very good security practice, but it's certainly viable and true. So if we were to go to the login classes activity here, it will eventually lead us into the util here, and from here we can see that we have a hard-coded username and password. So static analysis, what you're really looking for is just anything maybe out of the ordinary and understanding how your application works. Next is the passive analysis. So as mentioned, we are proxying the Android application and understanding perhaps maybe some underlying logging or just behavior that's going on. So here in Android Emulator, Android Studio, there is a cool utility called Logcat. Logcat allows you to look at the logs while your application is running. So if we were, to click into these different little dialog boxes, we're going to see a whole bunch of verbose logging. And one of the vulnerabilities that I found through research is this idea of insecure logging. So if we go back to JDEX and if we were to look at logs, what we'll see is that the username and password are logged. So if the attacker were able to perhaps proxy this device to deploy Logcat, for example, they could get username and passwords and extract those user accounts from there. So this is important to look into. Now there's other things that you can look into with passive analysis, including SSL pinning, which is looking at the SSL certificates that are pinned to the Android application, and you could perhaps intercept those. There's a lot of different things you can do with passive analysis. Finally, there is dynamic analysis. So as mentioned, I'm not going through an example or a demo here, but there are many different types of tools that you can use, one being Frida that I've found. Basically, what you're doing here is you're hooking into functions, you're attempting to understand and find out what's going on within your applications or code. So if you're a mobile app developer into mobile security, or you're just looking to understand how you defend against these types of attacks, really the key tenet here is to make it very difficult for attackers to decompile your application. This often means deploying code obfuscation to make your source code very difficult to read or understand, runtime protections to prevent tampering, and hooking to catch debugging attempts. So obfuscation makes your code very hard to read, almost impossible, very difficult. And ways that you can do this include randomizing variable names, strings, classes, encrypting various different types of functionalities within your application. When attackers use a reverse engineering tool, what they'll likely see is that they can't find cryptographic keys or hard-coded API keys, or maybe just even vulnerable code. And even though that you shouldn't have those things to begin with, it's still real. There are certainly dynamics elements out there. So obfuscation is all about slowing down the attacker when it comes to reverse engineering. They have to go and try to understand how it all works. Runtime protection protects the app against debugging techniques. So you're looking to see and detect if various different frameworks, such as Frida or exposed, are hooking into your function calls. Perhaps you're looking to see if the attacker is looking for real-time injection. So you're implementing runtime protection, and oftentimes this is done through even just catching an emulator or debugger within your environment. So when it comes to deploying these defenses, there are open source projects like ProGuard and R8 which help with optimizing the Java bytecode before compilation. ProGuard was developed by Guardsquare. DexGuard was later built on top of ProGuard, and Guardsquare, today's video partner, provides advanced tools to help with Android and iOS security. So DexGuard and IXGuard, which is the offering for iOS applications, don't just shrink your code like ProGuard, it adds a layer of advanced protection. This includes implementing advanced code obfuscation, including strings and class encryption to make it much harder to read the underlying app code. Control flow obfuscation to make the app's logic much harder to follow. The encryption of assets and resources. So it's not just the code you're going to obfuscate, make harder. It's actually the encryption of the static asset. And then you have the runtime protections to help detect tampering, hooking frameworks like Frida, as we've mentioned, and even rooted devices, which allow you to install non-standard apps, which may aid in helping the attacker hack the actual application. All of this really ultimately makes it much harder for the attackers to, of course, reverse engineer and try to find vulnerabilities within your applications. And as mentioned, there is an iOS offering called IXGuard, which provides various different frameworks such as React Native, Flutter, Unity, and many more. If you're interested in learning more about what the team at Guardsquare does and how they can protect your mobile applications, you can use the link in the description below. Thank you for today's video partner, Guardsquare, for sponsoring and helping this channel. So hopefully you've learned, I don't know, maybe something a small bit new here. I am still looking into how to do this myself. I created this video more so as a means of kind of reiterating what I've already learned. And well, you know what it is. Until the next time, have a good day.